Alright guys, welcome back from the break. Today's lesson 351 is all about comparing features of linear functions. We're going to focus on the y-intercept and slope, the average rate of change, given some different types of linear equations. So, remember, linear functions can be written in the form f of x equals mx plus b, which is basically just y equals mx plus b. M is the slope and b is the y-intercept. The rate of change can be found using the slope formula, which is right in the middle of the page here. The y-intercept is where it crosses 0, y, and the x-intercept, if there is one, is x, 0. The slope of both intercepts can be determined from tables, equations, and graphs. That's what we're going to be looking at today. It's tables, equations, and graphs to identify those connections, right? To compare, basically. All right. Pause that, read that, keep rolling on. Identify the rate of change in y-intercept in context. Make sure you read this. Read the problem carefully, look for information, make a list of what's known. Determine which information tells you the rate of change. Look for things like each, every, per, or rate. Those are usually a good hint. Determine which information tells you the y-intercept or the b value. That should be your initial value, your starting value, flat fee, those things we've mentioned so on and so forth over and over again. If you're looking at an equation, it should be in the form y equals mx plus b. Find the rate of change, the slope, m, and identify the y-intercept, which is the constant. From a table, pick 2 points. So the first will be x1, y1, x2, y2. Substitute the values in the slope formula. Identify the y-intercept as the coordinates in the form 0, y. If the coordinate is not given, substitute the rate of change in one coordinate, any coordinate, into y equals mx plus b, and then solve for b. Lastly, if we have a graph, choose 2 points, assign one to be x1, y1, the other one x2, y2, substitute the values in your slope formula, identify the y-intercept where it crosses the y-axis. Okay? Linear functions are increasing if the rate of change is positive. Linear functions decrease if the rate of change is negative. The greater the rate of change, the steeper it will be. If the rate of change is 0, it will be a flat horizontal line. Alright, so function f of x and g of x are described below. Compare the properties of each. So for this one, let's start with the y-intercept. y-int, which is 0, 8. If I look over here, my y-intercept is 0, -6. So the first one has a larger y-intercept, okay, the graph as opposed to the table. And then f of x, by the way. So the next thing I want to look at is what's my rate of change, so my slope. Well, you can either, it's a graph, we can count, rise over run, so I'm going down to right 1, down to right 1. So m is -2 over 1, which is just -2. Okay? Over here, I don't have that luxury. I don't have that ability. So I can do x1, y1, x2, y2. So -8 minus -10 over -1 minus -2. Okay, y2 minus y1 over x2 minus x1. So that would be +2 over +1, which is 2. So this one is actually increasing. This one's going uphill, while this one, the graph, is decreasing. So g of x is increasing, f of x is decreasing. So eventually they're going to cross somewhere. That's worth noting. And then we can also find the x-intercept. If we want to, 4, 0 on this one. You're not given the x-intercept over here, but if we were to keep the pattern going, we can find it pretty easily. 2, -2, and then 3, 0. So the x-intercept here is 3, 0. That's all we're doing, guys, is just comparing some properties or key features here. Increasing, decreasing, that sort of stuff. All right? So
We're gonna stop with that one, and then we'll put example 2 and 3 on a separate video.